Okay, in this lesson, we're going to talk about kinematics in calculus. So we will start with S here. It stands for displacement. So if this is displacement, what will V be? V is the change in distance over change in time. How do we express in calculus? ds over dt. Now it means this is change in the distance over change in time. Okay, next, how then we will get acceleration? It will be the change in speed over time. So it will be dv over dt. Now, acceleration means you go faster and faster and faster. So the speed changes over time. Another way to write this, if I want to go straight from S to A, how do I do it? I write as d to S over dt square. Okay, so in this lesson, we are just going to go downwards, straightforward. What does that mean? We are just going to differentiate. Okay, which is why we have these 5 parts here. Okay, before we start with the question, let's have some keywords. This is very useful. Look at the notes that you have. When we have the word initial, what must you use for mathematics? What is 0? Okay, so when you see initial, circle and then write down there, t equals to 0. Okay, initial speed, initial distance, initial displacement, initial velocity, doesn't matter, t is 0. Okay, the starting point. Mathematically, how do you express it? Starting point. At the start. What's happening? Mathematically. The S may not be 0. Time equals to 0 at the start. You should know this for Emaths. Fixed point. They will always, or they will sometimes say that there's a fixed point. Mathematically, how do you express it? The displacement equals to 0. Now, at the start, displacement may not be 0. Please take note of this. Instantaneously at rest. Mathematically, speed equals 0. S0 does not mean it's at rest. It just passed by the fixed point only. It has passed by. S is displacement, S is not speed. So you must say V equals 0. Please do not use S for speed. I am not the person who invented this, but we must all follow. S is for displacement. Turning point. Suddenly the object has to turn. Mathematically, what will happen? ds dt equals to 0. And we know that ds dt is actually your velocity. So at the turning point, v equals to 0. Now let's highlight this. Should I write v equals to 0 or a equals 0? Since when v is 0, a is 0, which one should I use? There's a big difference in the answer. Should I use v0 or a0? I should use v0. Please do not use a0. Because imagine I differentiate one more time already. I got some answer, I will lose some answer. Because t squared become t, right? T cubed become t squared. So I will lose numbers. So please do not use acceleration 0. Please don't do that. Just remember, turning points are when v equals to 0. Now, distance and displacement is inside a worksheet. They are not the same thing. Later we will see in part 4 what is the meaning of distance. We have to add up all the distance traveled from point to point. So they are not equal. And finally, what's the meaning of average speed? Total over total. Now this d here, is it the distance or the displacement? Yeah, please take note. It is the total distance. Please take note, it's the total distance over total time. Okay, let's start. Now, I have a particle. This topic is quite simple, really very simple. You just differentiate and integrate only. And then if you have the keywords in mind, you should be able to do it. So I have a displacement given by this equation. Find the initial displacement. How do I do that? The keyword is initial. So Yeah, lor. Why did I leave so little space here? Because just let t equals 0. When t equals to 0 and I substitute here s equals to 0 minus 0 minus 0 minus 8. And the answer is negative 8 meters. Now what does this mean? This means that it will be on the left side of the fixed point. It will be on the left side of the fixed point. Find the value of t. How do we do that? When the particle is instantaneously at rest. When you see the keyword, what must you write? Yes, just let v equals to 0. Problem. I have s, I got no v here. Yeah, so I want to find v, which is ds dt. So you realize for the past few days for Amax, when we see the question, we write down what we want to do later. So we convert all the English words to mathematical symbols. Okay, let's just differentiate. Very simple. I will have 6t squared minus 22t minus 4t. How do we find t now? We will let this be 0. So I divide by 2, I divide by 2, I divide by 2. I let it be 0. I'll have 3t squared minus 11t minus 20 equals to 0. So I have 3t plus 4. I just use the calculator, but please write down the working. 3t plus 4, t minus 5 equals to 0. T equals to negative 4/3 or t equals to 5. Yeah, t cannot be negative. So in Amax, you must find and reject. If you never reject or you never put the negative 4/3, you will not get the answer mark. You must find, reject. Amax is compulsory. Okay, so t will be 5 seconds. Okay, this part here is very, very important. How do you think we will find the distance in the 5th second? Let t be 5. This is not totally correct. Okay, so when t is 5, our displacement will be 2 times 5 cubed minus 11 times 5 squared. Please use the correct equation. Minus 40 times 5 minus 8. Negative 233 meter. So what is the distance in the 5th second? Yeah, you're right. This is displacement. So what is the distance in the 5th second? How do you get it? The 5th second means from the 4th second to the 5th second. That's the definition. You must memorize and remember this. That means it will be from the previous second to the next one. What do I have to do? Substitute t equals to 4. So s equals to 2 times 4 cubed minus 11 times 4 squared minus 40 times 4 minus 8. You get negative 216. Let's answer the question. What is the distance during the 5th second? So what's the distance? So I prefer to use big minus small. So the distance, just get used to. Get used to this. I'll always use the big minus the small. It is okay to write 233 minus 216. Most of you will write like that. And the answer is 17 meters. Okay, this is the highlight of the whole lesson. After 10 seconds, how much did it travel? You have realized by now I don't have distance formula. I only have displacements. How do I use displacements to find distance? Okay, so there's a trick here. Everyone, always write this down. Start, turn, end. There may be a lot of turning, doesn't matter, it's very simple. I will see where I start, where I turn, or the places I turn. There may be 2 or 3 times you turn. And then finally where I end. So what's so special about turning? How do I find where are the turning points? Look at the whiteboard. How do I find where are the turning points? Okay, so turning point is when V equals to 0. Okay, let's write down this. I will show you diagrammatically why it's like that in a while. Starting point, T equals to 0. The turning point was T equals to 5. And I end at T equals to 10. So I need to find the displacement when the time is 0. What's the displacement? I should have found most of them here already. What was the displacement? Look at the... Yes. So please don't go and redo everything again. You're wasting your time. Go and look at the previous parts. You notice that it's negative 8. The turning point, did I find just now? What was the displacement? Negative 233. Down here. Okay, the last one sure don't have lah. So when T is 10, what is S? When T is 10, I'm not going to write it down lah. What is S? Can you just work it out? Did you get 492? So now I want to find distance. Big minus small. All you need to do is draw this. No, draw this. Draw this. I will use the big minus the small. So the distance is like this. From here to here, I use the big minus the small, which is 233 minus 8 is 225. Here, I use the big minus the small. Now you know why it's important to use big minus small? Because you'll be using 492 minus, yeah. And the distance is 725. So what's the total distance? Total distance right here is equals to 725 plus 225 equals to 950 meters. Okay, your question now is why are we doing this way? I'm going to draw out for you once, but please don't need to draw during exam. Okay. T equals to 0. Don't have to be at the center lah. I don't care where it is, just somewhere. Then the distance here is negative 8. After 5 seconds, I move to the left or right. I move to the left. S equals to negative 233. Again, you have to do this next time once you remember the steps. What is the distance? How do you get 225? Yeah, 233 minus 8, right? Now, after 10 seconds, where is my particle now? After 10 seconds. Which side? Left side, right side? Yeah, it's not here, it's not here, it's all the way to here. What is that? Displacement? No, the displacement is 492 first. Okay, you realize that I am traveling now from here to here. How long is this? Seven to 5. Okay, I will draw out the path now in black color. Okay, the path looks like this. Let me. Okay, this is the consider the last part already because the last one very simple. Okay, I start with this. My particle move to the left, and then what happened to the particle? It stopped and then it go back. So the question is find this dotted line, how long it is. Are you going to draw during O level? Please don't draw leh. Okay, use the method here. Start, turn, end. What is the average speed? This is the easiest. Yeah, so average speed is just the total distance add together over total time. Okay, that's all for